Hello students, I welcome you all for today's class. I hope everybody are doing good. So before we move on to today's class, I'll do a recap of what we learned in the previous class, okay? So first, we looked into numbers, right? So in numbers, you learned what are odd and even numbers, what are factors and multiples, what are prime and composite numbers, the divisibility of numbers and prime factorization by division method and factor tree method, right? So in today's class, I'll be solving exercise 1.1, okay? So that is, I'll be solving problems based on what we learned in the previous class. Understood, students? Now we'll move on to the problems. I'll start from third sum, okay? So the first two sums will be solved in the Zoom class. So the third question is write the smallest and the biggest two-digit prime numbers. So what is a prime number? We have already seen in the previous video, right? So a number is said to be a prime number if it has only two factors, that is 1 and the number itself, okay? So such a number is said to be a prime number. So the smallest two-digit prime number is 11 and the biggest two-digit prime number is 97. Okay, now I'll move to the fourth question. Write the smallest and the biggest three-digit composite number. So what is a composite number, students? So a natural number having more than two factors is called a composite number, right? So the smallest three-digit composite number is 100 and the biggest three-digit composite number is 999. Understood, students? We'll move to the fifth question. The sum of any three odd natural numbers is odd. Justify the statement with an example. So the solution is the given statement is true. Okay, the sum of any three odd natural numbers is odd. For example, I have taken 3, 7 and 9. Okay, so when I sum up these three numbers, I get the value 19. So 19 is also odd. How do I say that 19 is odd? Because it one's place ends with 9. So numbers ending with 1, 3, 5, 7 and 9 are said to be odd numbers. Understood, students? Now I'll move to the sixth one. The digits of the prime number 13 can be reversed to get another prime number 31. Find if any such pair exists up to 100. So what are they saying? The digits of the prime number, for example, 13. Okay, when it is reversed, we get 31. So 31 is also another prime number. Okay, so you are supposed to find out if any such pairs exist up to 100. Okay, so the solution will be 17. So when I reverse 17, I get 71. Okay, so 71 is also a odd number. So the pairs are 17, 71, 37, 73 and 79, 97. Understood, students? The seventh one is your friend says that every odd number is prime. Give an example to prove him or her wrong. So the solution is the given statement is wrong. So every odd number is not a prime. Okay, for example, I have taken 9. Okay, so 9 is an odd number, but it is not a prime number, right? Even 15 is an odd number. It is not a prime number. Okay, so the given statement is wrong. That is, every odd number is not a prime number. Understood, students? Now I'll move to the eighth question. Each of the composite numbers has at least three factors. Justify this statement with an example. So the solution is the given statement is true. Each of the composite numbers has at least three factors. Okay, for example, I have taken the composite number 4. Okay, so the composite number 4 has three factors, namely 1, 2 and 4. We have already learned in the previous video, right? What are factors? So a factor is a number that divides into that number exactly, leaving no remainder. Okay, so therefore the composite number 4 has three factors, namely 1, 2 and 4. Understood, students? Now I'll move to the ninth one. Find the dates of any month in a calendar which are divisible by both 2 and 3. Okay, so the number of days in a calendar are 30 and few months have 31 days, right? So every month, the dates 6, 12, 18, 24, and 30, excluding February, okay, are divisible by 2 and 3. Okay, understood, students? So the number of days in a calendar are 30 and 31, depending upon the months. Okay, so every month, the dates 6, 12, 8, 24, and 30, excluding February, are divisible by 2 and 3. Okay, now I'll move to the 10th one. I am a 2-digit prime number and the sum of my digits is 10. I am also one of the factors of 57. Who am I? So what is the question given? So they are saying that a number is a 2-digit prime number and the sum of its digits is 10. Okay, and it is also one of the factors of 57. Now you are supposed to find that number. Okay, so the number is 19. 19 is a factor of 57, and when you add 1 and 9, that is sum of the digits of 19. When you add 1 and 9, you get 10. Okay, and 19 is a 2-digit prime number. Understood, students? Now I'll move to the 11th one. Find the prime factorization of each number by factor tree method and division method. Okay, so the first one is 60. So I'm going to prime factorize the number both by factor tree method and division method. Okay, so 60 can be divided in two tables 30 times. Okay, so two 30s are 60. Again, 30 goes in two tables. So two 15s are 30 and 15 goes in three tables, which is 3 5s are 15 and 5 goes in five tables. That is one time. Okay, so 60 can be written as 2 multiplied 2 multiplied 3 multiplied 5. Understood, students? So this is the division method. And next I'm going to move to the factor tree method. So 60 has factors 2 and 30, 30 as factors 3 and 15, and 15 as factors 3 and 5. Understood, students? So this is the factor tree method. We have already seen this in the previous video, right? So the answer for this question is 2 multiplied 2 multiplied 3 multiplied 5. Okay. Now the second one is 128. Likewise, 128 gets divisible in two tables, right? So 264s are 128 and 64 gets divisible by two tables. 232s are 64. Similarly, 32 goes in two tables. 216s are 32. 2 8s are 16. Likewise, 8 gets divisible in two tables. Two 4s are 8 and 4 gets divided in two tables, that is two 2s are 4 and 2 gets divided in two tables, which is exactly 1. Okay, so two 1s are 2. Therefore 128 can be written as 2 multiplied 2 multiplied 2 multiplied by 2 multiplied by 2 multiplied by 2 and 2. Okay, so therefore it has 1 2 3 4 5 6 7. So it has 7 2s. Okay, so this is the division method. Now I'm going to move to the factor tree method. So 128 as two factors, that is 2 and 64. Okay, so 128 gets divided by two tables 64 times, and 64 gets divided by two tables 32 times, and 32 gets divided by two tables 16 times, and 16 gets divided by two tables 8 times, and 8 gets divided by two tables 4 times, and 4 gets divided by two tables 2 times. Okay, so this will be the answer for this question. Understood, students? So the rest of the questions I've given it in the worksheets. Okay, now I'll move to the 12th question. If there are 143 math books to be arranged in equal numbers in all the stacks, then find the number of books in each stack and also the number of stacks. Okay, so what is given in the question? They have given the total number of books, that is 143. Okay, and what are you supposed to find? The number of books in each stack and the number of stacks. Okay, so the solution is I'm going to factorize 143 by division method. Okay, so 143 gets divided by 11 tables exactly 13 times, and 30 gets divisible by 13 tables one time. Okay, so the factors of 143 are 11 and 13. So therefore the number of books in each stack and the number of stacks may be 11 comma 13 or 13 comma 11. Understood, students? So these are the sums in exercise 1.1. Okay, now I'll do a recap of what we learned in today's class. In today's class, we looked into problems in exercise 1.1, right? So I have solved problems based on odd and even numbers, factors and multiples, prime and composite numbers, divisibility of numbers, and prime factorization. Okay, so in today's class, we discussed problems in chapter 1, that is numbers. Okay, so the third question was you are supposed to find out the smallest and the biggest two-digit numbers, which are 11 and 97. And the fourth one is you are supposed to find the smallest and the biggest three-digit composite numbers, which are 100 and 999. Okay, and the fifth one is they are asking us to justify the statement with an example, and the statement is the sum of any three odd natural numbers are odd, which is true. Okay, so when I add 3, 7 and 9, I get 19, which is odd. Okay, therefore the given statement is right. And next I moved on to the sixth sum, that is the digits of the prime numbers 13 can be reversed to get another prime number 31. So they are asking us to find out if any such pairs exist up to 100. So the solution is 17, 71, 37, 73 and 79 and 97. Okay, and next is your friend says that every odd number is a prime and you are supposed to prove them wrong with an help of an example. Okay, so every odd number is not a prime. For example, 9. So 9 is an odd number, but it is not prime, right? And next we moved on to the eighth sum. They are asking each of the composite numbers as at least three factors, and they are asking us to justify the statement with an example. Okay, so this given statement is true, so each of the composite numbers has at least three factors. For example, I've taken 4, so 4 has three factors, namely 1, 2 and 4. Okay, and next I moved on to the ninth sum. So you are supposed to find the dates of any month in a calendar which are divisible by both 2 and 3. So the number of days in a calendar are 30 or 31. So few months have 30 and few months have 31 number of days. Okay, so the every month the days 6, 12, 18, 24 and 30 are divisible by 2 and 3. Okay, and next we moved on to the 10th sum. I am a two-digit prime number and the sum of my digits is 10. I am also one of the factors of 57. Who am I? So the solution is 19. So 19 is a two-digit prime number and the sum of 19 is 10. Okay, and it is also one of the factors of 57. And next we moved on to the prime factorization of each number by factor tree method and division method, right? I hope you would have understood, students. And next we moved on to the last sum, that is if there were 143 math books to be arranged in equal numbers in all the stacks, you are supposed to find the number of books in each stack and also the number of stacks. Okay, so factorizing the given number, I get two factors, that is 11 and 13. So the number of books in each stack and the number of stacks may be 11, 13 or 13, 11. So that's it, students. I have attached the worksheets for you. Kindly try solving in your notebook. Thank you, students.